Hello everyone. For this tutorial video I like to talk about thermal expansion, which is when an object grows or shrinks in response to temperature. We remember from a previous tutorial video that the scientific definition of temperature is the random motion of the particles or molecules that make up a substance. So when we observe the red part in a thermometer expanding because it gets hotter, we can guess, based off this theoretical definition, that the explanation of why it is getting larger the hotter it gets is that the particles move faster and so push each other out. And in fact, thermal expansion is not limited only to thermometers, but describes almost anything that grows and shrinks in response to temperature. For example, a warmer or hotter gas will rise up compared to the colder gas beneath it, because it has expanded more and so is less dense than the colder gas beneath it. And you will also see that engineers have to pay attention to designing railroads to have spaces or joints for expansion to occur, because if there is not enough room, the expansion of the tracks against one another will cause the system to buckle. And we do not want that to happen in order for the train to ride safely over it. So with all this out of the way, we can predict that, in a mathematical statement, if there's expansion along only one dimension, the change in length equals the original length times the change in temperature times the property of a substance called the coefficient of thermal expansion, which refers to how severely an object grows or shrinks in response to a temperature change, and is always different for different materials. So there's no one universal answer that works for them all, but rather they are measured on a case-by-case basis. Although a general rule you can use is that if you know a material is a better conductor of heat or conducts heat faster, then you can guess that it will also have a larger coefficient of thermal expansion, which should make intuitive sense somewhat, if you know by the simple fact that something conducting heat better means it gets hot quicker. So it should expand more because the formula states the change in length is proportional to the change in temperature. So next, we can deduce a formula for 2- and 3-dimensional expansion as well, by stating that is equal to 2 times the coefficient of expansion times the original area times the change in temperature for change in 2D area, and for change in 3D volume, it is 3 times the coefficient of thermal expansion times the initial volume times the change in temperature, which should make sense if you're familiar with how 3D geometry works. Now that we have gone over how thermal expansion works, including deriving formulas for it, we can discuss how temperature is related directly to the pressure of a gas, which is important for something like a car tire, and is called the ideal gas law, as a reference to how a gas should theoretically or ideally behave. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.